It's George Tyndall, and I'm back again. And this time we're going to talk about two specific things. We're going to talk about the Earth and its core, and then we're going to talk about something that not even the experts know. Because you don't know if you don't find stuff and you're able to look stuff and come to a conclusion. We're going to talk about what is called a nuclear comet. And I'm going to get into that and I'm going to explain that. But first we're going to go with the core of the Earth. Now everybody's having a hard time being able to figure out why things work the way they do. And they're not sure on this and they're unsure on this. And it's theory this and theory that. Well, I have the chance to put my own ideas and my own theory out there. And this is what I'm going to do. Because it absolutely makes more sense than anything that I've heard from a lot of people out there. Now, the Earth's core is like the sun because of how hot it is. It is a fusion reactor. Roughly 450 miles long. It generates a magnetic field. The layer surrounding the core. This layer surrounding the core is made of materials that have a really super high melting point that will hold all the heat in and allow it to do what it do and for it to generate. It's no different than when a person builds a nuclear fusion reactor. They have to have an outside substance that doesn't melt. Now, the underground ocean, which scientists discovered, the underground ocean is part of the cooling system to help keep the core of the Earth cool. There are vents, like lava tubes, that surround the outer core that allow heat and steam to move to the Earth's surface, toward the Earth's surface. These tubes, now I'm not sure because I don't have the technology. I'm not sure if the tubes run through the ocean and the ocean helps keep the tubes cool where the heat's going through. I'm not sure. I can only guess because I don't know whether the ocean, I don't know if it surrounds the core completely or not. Okay. The tubes that allow the heat and the steam off of the core, there's a good percentage of a chance that they most likely feed into the magma chamber somewhere, which causes the rock to stay hot continuously. But the gases and the heat and everything will build up in the magma chamber. When that does, you'll have your volcanic eruption where your heat and your gases are released. It's like a release valve. It'll shoot it out, and then it'll stop, or it'll either shut down. Now, the North and the South Pole, these areas here, they help keep the Earth's core from generating too much heat. And so does the ocean. And the underground ocean. So you have the poles, you have the ocean water, and you have the underground ocean. They all work together as a cooling system for the core of the Earth. Now, Galileo's theory of tides, Okay, theory. It was so somebody could go back and somebody could check this stuff out. That's why he left theory in there. So somebody could go back and they could either add or check out. If Galileo had known that there was an ocean at the center of the earth, he would have been able to come up with what I'm coming up with now. But that wasn't available to him. And it's not these people's fault that years ago the science wasn't available to them. What is sad right now is the science is available there and people can't put this stuff together. Now, when the tide goes out, doesn't everybody ever wonder, well, where does all that water go if it's going out? Okay. When the tide goes out and comes in is when the water exchange takes place in the ocean that's underneath the ground. Okay. That happens so the underground ocean doesn't overheat. Now, when it's exchanged, the cold water, when the tide goes out, the cold water goes down into the underground ocean. And somewhere along the line, when it comes back in, it's forced back up the warm water. It's sort of like some kind of a gravity flow system. And it's down at the deepest part of the ocean where nobody can get to. Nobody can get to. You can't see what's down there, so you don't know. You have to kind of guess a little bit. But that makes sense when the water goes out. Okay, well, where is all that water going? Okay, the water's being displaced, so it's going somewhere, which makes logical sense that it's going down to that center ocean to put cold water into it and push the warm water up. Now, this is why you have warm and cold currents in the ocean. And that would make complete sense. But like I said, whether people want to listen to it or not, you don't have to. You don't have to listen, okay? I'm not making anybody listen. Anybody can call me dumb, stupid, whatever they want. I don't care. And I'm not going to respond to anybody anymore. I'm just not. They can put up there whatever they want, say whatever they want. I'm not going to respond anymore. I'm done. Now, since I've already discussed that, I'm going to discuss a couple other things. And this will help clarify things that people can't figure out or they don't understand. It has to do with researching, looking things up. Now, there's such a thing called a sun grazer comet. Okay, that's a comet that gets really close to the sun. But nobody took into account what happens to that comet when it gets close to the sun. What does it do and how does it react? Okay, we know what comets are composed of, and you know what the sun is composed of. The sun is composed of a lot of radiation. The closer that the comet gets to the sun, the more nuclear fused it's going to be. Yes, a nuclear fused comet. And it can happen. It can happen from the vacuum in space, the solar radiation, and everything that's on the comet. All the rocks, the dust, the minerals, the gases, and you can look it up. And this is something that nobody's ever really gave the thought. What it does to the comets when they pass, especially if they pass it in 300,000 miles or closer. Now, why do I come up with nuclear comet? Because there's some pieces that I found, and I'm going to go to those pieces in a minute. But I'm going to also explain why Venus is hot and has no cooling system for its core. If it has a liquid core and there's no cooling system, there's no water or air on the planet whatsoever to make things cool, you're not going to be able to cool the planet. The planet's not going to melt down, but all the heat that's generated in the center is going to work its way out. That's why you have an 800-degree temperature. Now, as far as Mercury having a core, I don't know about that. But if Venus has a liquid core, it's a good chance that at one point in time, it probably had water and air on it too. But I'm guessing at things, okay? I can't put everything together. Now, the reason why I came up with the nuclear comet thing is the thing I've been finding out about Mars and some of the rocks that I've been finding. I believe that Mars had water and air. And maybe an atmosphere similar to Earth. What is the red stuff on the Mars planet? The red stuff. It's covered with red thermal oxidation. And you have to look up thermal oxidation to understand what that is. I didn't even know it until I looked it up. But that's one reason why the planet is so dry. No water, no air. My guess is, and I'm going to take a guess at this, judging by the craters, one of those sun grazer comets went nuclear, came around, and slammed into Mars. And that would explain the tremendous heat, why a lot of the Mars rocks have there's so much oxidation laying on the planet, and why a lot of the Mars rocks actually have metal coatings on them. Because they got extremely hot. But those are guesses. Okay? I don't want to say for sure because I don't know. And I don't even want to say for sure that I'm 100% right with the Earth thing. But I think I'm closer than anybody's ever been because it seems to make more sense. But I will leave it up to you people. As do you want to know or not? Now, after finding that out, the sun grazer comets are probably more dangerous than any of the asteroids out there, especially if they go nuclear and they convert, which they can convert. Getting closer to the sun will convert rocks, metals, and minerals because of the high heat. Now, if you want to call me dumb, stupid, hey, that's fine. People are allowed to do that. Like I said, I'm not going to respond to people anymore. But the stuff that I'm finding points me in that direction. And when you find stuff like this, if I had the equipment and the microscopes and the stuff and I could test this stuff, I would know 100% sure. But I can tell by looking at it and looking at pictures of rocks from nuclear test sites where they exploded nuclear bombs. They look exactly like this. This stuff has been altered. Okay? This has been altered. It's been, exposed to high temperatures and pressures. And what makes me think nuclear is because of stuff like this. This is a piece of metal, but the outside is like rock. It's like in rock form. And why did it change color? Why is it white? Because if it was exposed to a lot of nuclear radiation, that's what it would do to the gray color of the rocks in space. Same with this one here. These are not normal Earth rocks. And this isn't rust, this is burnt. But it's where the black burntness wore off. It turned that color because that used to be black. This stuff was buried in the ground. Same with a piece like this. This has been altered. The metal, the rock, the minerals, everything fused together. And it was probably done because it got too close to the sun. and all the crystals and the metal and stuff, they all changed. Some of this stuff looks really bizarre and some of it looks really fascinating. But I've been trying to figure out why a piece like this could be metal. And you can hear it. It's metal, but it's a different form of metal, but the metal mixed in with everything. Everything fused together. Now, all you people out there, like I said, you can doubt what I say. I'm putting my findings out there. I'm putting my findings out there of what I found, okay? And I should be allowed to do it just like everybody else. My question is how is NASA going to stop a nuclear comet if, in fact, I am correct? My findings are correct. How are they going to stop a nuclear comet? Because the comet, those pieces, they alter and they change, and they could become more dense and more heavier and more stronger. So, how will they stop a nuclear comet? You know what? I'll leave that up to them.